Hello. Today I'm going to be talking about water. I assume that everyone watching this knows what water is, unless they've been living on a rock their entire life. In which case, I'm actually quite impressed. And can you tell me how you're doing it? But anyway, let's get on with the video. You're probably saying, why are you making this video? Water's just a boring, mundane substance that we drink every now and then when we get thirsty. To which I say, you're right. Until you look really close at it. No, you need to look much closer than that. Water's made up of two different elements. Oxygen and hydrogen. I know, so complicated. But it's the interaction between these two elements that give water pretty much all the properties we actually care about. Like that helping us live thing. Water is a polar molecule, which simply means there's a positive and negative charge. Kind of like a magnet. This polarity is caused by the oxygen molecule attracting the electrons close to its nucleus than the hydrogens do. Just like that one guy who doesn't like sharing his stuff. Since the electrons are close to the oxygen side of the molecule, that side becomes electronegative, and the hydrogen side becomes electropositive. We call the charges delta positive and delta negative after the Greek letter for D. Delta just means a change, but since it's lowercase in this change, it means that the change is only very small. This means that the hydrogens are attracted to the oxygens of other molecules, forming what we call hydrogen bonds. Yay! The presence of these weak hydrogen bonds in water, even though individually they are very weak, together create a fairly substantial force. Now that we've explained what hydrogen bonds are, let's get on to some actual properties of water. I know, like, talk about relevant stuff. Ice is less dense than water. There, I've said it. At this point you're probably thinking, yeah, duh, obviously ice floats when I put it in my glass of water. But this is actually a really big deal. I mean, try and think of another chemical which is a solid state that floats in its liquid state. You probably can't. I know I can't. So yeah, big deal. But why does ice float? It comes down to hydrogen bonding. You see, I said they would be important. The thing with chemicals, when you look at them at a molecular level, is that the hotter something is, the more energy it has, which in most cases mean that when you heat it up, the molecules spread out and get less dense as a result. Now you do the same with water. You heat up ice and melt it, it gets denser. Since the H molecules in ice aren't really moving around much, they form loads of hydrogen bonds with the molecule around them. This gives ice a regular crystal shape, and the molecules are kept away from each other. You then look at water. All the water molecules are moving around each other, which means fewer hydrogen bonds are formed, allowing the molecule to be much closer together, and as a result be denser. For an example of this phenomena, all you have to do is look at a frozen pond with fish in it. The ice floating on top insulates the rest of the water, stopping it from freezing, leaving the goldfish to live for another day. Cohesion and adhesion. Similar words for similar things. Put simply, cohesion is sticking to itself, and adhesion is sticking to other things, which is why glues are called adhesives. The more you know. Cohesion is the reason that water drops form drops and droplets, and adhesion is why you get these drops of water suspended impossibly off the bottom of leaves. Come on, just fall already! To show this effect better, let's shrink down to the size of ants. Geez, ants are actually really scary looking. Now, if we put a drop of water on the ant, it will get stuck in the little bubble. The ant is too small and weak, however, to break the surface tension of the water, which is an effect of cohesion and adhesion, and therefore it gets stuck in the bubble. Right, let's get back to normal side before physics does some wacky stuff and decides to destroy the world. Plants do all sorts of wacky stuff with adhesion, including pumping water up a 100-foot high tree. I mean, seriously, without a pump or anything. I mean, it's just insane. Humans use it too in our capillaries, the smallest blood vessels in our body, an effect called capillary action. Have you ever seen water flow up tiny tubes, even though it seems impossible due to gravity? Well, that's capillary action. The body uses it to help keep the blood travelling through these tiny blood vessels. Water has a very high specific heat capacity and latent heat of vaporization. What specific heat capacity is the amount of energy needed to heat up a chemical 1 degree centigrade. Sorry to people who use Fahrenheit. I mean, get with the times. America! Sorry, I don't know what happened there. Water's specific heat capacity is 4.2 joules per gram per degree centigrade. In comparison, iron's is 0.46 joules per gram per degree, and glass is 0.8. Whereas the latent heat of vaporization is the amount of energy to change the state of the liquid into a gas. Water also has a high one of these, on top of its high specific heat capacity. What this means is water is very good at absorbing heat and taking it away. Sounds like a good coolant. Which brings us to sweat. A thin layer of water spread over a large surface area on our body, which we formerly know as skin, which helps us cool down our body. Water can dissolve anything. Well, not anything, but it can dissolve a heck of a lot of stuff, i.e. all ionic compounds and polar molecules, which hint there are quite a few of. Thanks to this miracle solvent.
What about the juniper bushes over there? He has made the bush fruitful by his word.
Our body has the ability to move everything that it needs in our blood. This is not to say that everything in the blood is dissolved in water, but a good deal is, which again helps us with the living thing. Since I feel I'm waffling on a bit, I think it's time to wrap up. At this point, if you still don't think that there's more to water than meets the eye, then I feel you weren't actually watching this video and you wasted both your time and my time. Hope you feel good about yourself. Cool.